Welcome to This Explainer. Today, we're diving into something absolutely fascinating, how AI has evolved from a simple code completion tool into a massive, holistic ecosystem capable of managing your entire software development lifecycle. We are moving far, far beyond simple autocomplete here. We're looking at how artificial intelligence is fundamentally rewiring the way engineering teams plan, build, and maintain their codebases.
To kick things off, let's ask a pretty provocative question, one that is literally reshaping engineering teams as we speak. What happens when your AI copilot starts doing the chores? Think about all that routine upkeep, the branch naming, the context gathering, the technical debt management. What actually happens when developers are freed from those repetitive, tedious tasks and can truly operate as high-level systems thinkers?
Well, here is our roadmap for today to answer that. We'll be exploring Section 1, the Copilot Native Workspace. Then Section 2, Intelligent Branch Management. Section 3, Parallel Coding with Worktrees. Section 4, Automating Repository Upkeep. And finally, Section 5, Conquering Technical Debt.
Okay, let's jump right into Section 1, the Copilot Native Workspace, from idea to first commit.
Imagine having a literal second brain working right alongside you. You can start right at the origin. Maybe it's just a GitHub issue or repository with nothing but a simple idea. From there, the workspace proposes a step-by-step plan based on its deep, contextual understanding of your codebase. Then it built out the code, all while keeping every single line fully editable by you. And finally, it lets you run and validate that code directly in the browser or an underlying codespace. It's essentially orchestrating a seamless flow using natural language from start to finish. Moving right along to Section 2, Intelligent Branch Management, focusing on naming and organization. Think of it like space operations. Every vessel needs a clear designation, right? Well, Git branches are no different. Establishing clear, strict naming patterns, such as feature / for new functionality or hotfix / for critical production fixes, ensures your entire team instantly understands the mission of every single branch. And the cool part is, your AI copilot can actually analyze issue descriptions and suggest optimal names that perfectly match your team's specific culture. There is a striking difference here when you compare the two. Look at the old manual approach, where developers are kind of relying on clunky, inconsistent names based on guesswork. Contrast that with the Copilot Enhanced method. The AI instantly generates standard compliant semantic branch names directly from your project's context. It makes your version control history read like a clean, well-organized story. But listen, implementing AI branching requires strict discipline. It really does. You absolutely must follow core team integration best practices to maintain a healthy repository. You've got to establish clear conventions before leaning on AI suggestions. Make sure you include ticket numbers and use descriptive keywords. And hey, when you let AI generate Git aliases to speed up your workflow, test them safely first. Seriously, never let AI override your core Git commands. Which brings us to Section 3. Parallel coding with worktrees, or running multiple agents. So what if you have a massive backlog and you want AI to work on multiple features at the exact same time? Well, if two AI agents run in the exact same terminal, they're going to read and write to the same files, essentially overwriting each other and breaking your code. Total nightmare. The solution isn't changing the AI, it's changing how you use Git. Enter Git worktrees. This simply means decoupling the working tree, the actual files you see on your disk, from the repository object store. I absolutely love this analogy. Your main repository is the source of truth, and each worktree operates as an independent satellite. They all share the same remote history and commits, but each worktree lives in a completely isolated folder on your local machine. So you can have one AI agent building out a back-end database integration in one directory, while another AI agent is simultaneously updating the front-end user interface in a completely different directory. Zero overlap, zero conflicts. Now, this is where it gets really fascinating. You can use this for an agent versus agent setup if a task is super risky or complex. Just give two agents the exact same prompt in two separate worktrees. You are granting yourself free architecture exploration. You literally have two different LLMs building out competing solutions simultaneously. You review both outputs, pick the better one, and toss the other. It's the same amount of time, but with half the opportunity cost. All right, let's look at Section 4, Automating Repository Upkeep, basically delegating the maintenance. As your parallel agents push massive amounts of code, your repository is inevitably going to get cluttered. That brings us to agentic workflows, which GitHub is testing right now. This is a system where developers just write plain language instructions in Markdown files. Those files then trigger AI models like Claude, Copilot, or Codex to automatically manage unstable pipelines, review issues, or update stale documentation directly through GitHub Actions. You no longer have to script every single step in YAML. The AI just interprets your intent and acts as a brilliant layer of automation.
A perfect example of this automated housekeeping is branch cleanup. Think about developers who work on and off a project and totally forget to clean up their workspaces. Tools like the Remove Stale Branches action will automatically flag a branch if it hasn't seen a commit in 90 days. It pings the author with a comment, and if they don't do anything, the AI-driven workflow just safely removes the clutter, keeping your repository incredibly clean.
Now, while the efficiency is unbelievable, we have to impartially note the very real concerns the industry is grappling with right now. First up, rising compute costs from triggering LLMs every time a build or pull request happens. Second, strict governance and audit trail requirements, especially if you're in a highly regulated industry. And finally, by embedding AI orchestration natively into a specific platform's actions, teams are definitely facing the potential for tight platform lock-in.
Finally, let's wrap up with Section 5, Conquering Technical Debt, focusing on long-term code remediation. Let's face it, every enterprise has legacy code. Tech debt is just inevitable. But modern AI tools don't just write code anymore. They actually act like detectives. They analyze version control data to detect behavioral hotspots and code smells. They use historical data to predict future defects before they even escalate. They dynamically prioritize your refactoring efforts based on complexity, and get this, they can even accurately estimate the cost and effort required to fix those specific tech debt items. To make all those insights actually actionable, tools like the Modernization Lifecycle Platform, or MLP, embed AI directly into the pipeline. By providing a unified framework, these platforms give enterprises a tangible, highly automated path to modernize everything, from incredibly complex distributed systems all the way down to legacy mainframes. It literally turns static code analysis into orchestrated, measurable modernization with full traceability. To conclude our explainer today, I want to leave you with this one final thought. As these agentic ecosystems rapidly take over the heavy lifting of code creation, parallel branch management, and repository maintenance, how do you plan to balance human oversight with AI automation? The tools to operate as a high-level systems thinker are right here, right now. It's totally up to you how you deploy them. Thank you so much for joining me, and keep exploring.